Good morning, dear students. I am Dr. Srinivas Patini, Professor of Chemistry, Sri Academy, Hyderabad. So today, second class of IIT Organic Chemistry, that is Nomenclature of Organic Compounds. In the last video, that is introduction video, first video, what we have discussed, just the chemical nature, chemical bonding nature of the few atoms like carbon, nitrogen, oxygen, phosphorus, chlorine, sulfur, especially carbon, nitrogen, oxygen and hydrogen. So these are very, very important. Among these, carbon and hydrogens are very, very important. They play very important role in the nomenclature. Okay. So if you know the names, that will be very useful to study the further organic chemistry. If you don't know names, how can you call? So the naming is very important. Without name, we have lot of confusion. What is what? Who is who? So that is the reason. Because the reason why they are giving the namings, the International Union for IUPAC names, we can say. I will tell you later that IUPAC name. But first of all, you have to study the just few things you have to remember. Then that will be very useful according to IUPAC. So why? Because these names, why they are giving? Because the reason. So every day the millions of organic compounds, every day millions of organic compounds are being invented by scientists. So a lot of confusion is there. That is the reason some rules are there. How can you give that? It's very easy. One by one you have to study. Okay. So among all these compounds, all these elements, nature, yesterday we have studied, but especially carbon and hydrogen. Hydrogen and carbon. Because hydrocarbon, hydrogen and carbon. Carbohydrates, different types of are there. Carbon, hydrogen and oxygen, carbohydrates. Hydrogen and carbon, hydrocarbons. So that is a different story. So before going to that, we have to study that carbon and hydrogen nomenclature. In this, the first few things we have to remember. What are that? First of all, one alk group. Alk group you have to remember. Alk. Alk means that is represented by the R. Okay? Alk. You have to remember. Alk means, alk is a group. Okay? It is in a group. So we can say R. R means alk group. Alk. So we take the carbon. Carbon 1. One carbon. Second carbon. Third carbon. Fourth carbon. Fifth carbon. Sixth carbon. Seventh carbon. Eighth carbon. Ninth carbon. 10th carbon. So we have to remember 10 enough, no need to study further. Just you have to know at least 10 carbons. So what is the alk for one carbon? Alk for one carbon. But just you have to remember. These are very, very important. These are the fundamentals. Directly they will not ask you this. These are the things in IIT. Just we have to know the how to give the names. That is very, very important. Okay. So here carbon, one carbon is equal to meth. You have to remember meth. Just meth. Next second eth, prop, but, pent, X, et, oct, Oct means 8 number of carbons. Oct, non, dec. Dec means 10 carbons. You know the 10 carbons are present, so we can say that is dec. So all group, just we have to know that what are that all groups are, just we have to the number of carbons. If one carbon is there, meth, two carbons are eth, prop, but, pent, ex, ept, oct, non, dec. So these are very, very important, you have to remember. If one carbon is there, that is called meth. I will tell you later everything. Just you have to remember all these things. So up to 1 to 10, you have to bad. You have to completely bad. Like A, B, C, D. Then you have to remember one carbon, meth, second carbon, eth, third carbon, prop, fourth carbon, but, pent, ex, act, oct, non, 10, decade. Dec. That's all. So one more thing I will tell you. If a single bond present between two carbon atom is called ane. Just remember, if single bond between two carbon atoms, single bond, yesterday I told you how many electrons? 2 electrons. Don't forget this one. Single bond present between two carbon atom is called ane. If double bond a double bond is present between the two carbon atoms is called ene. You can say ene. Double bond is ene. Single bond is ane. If a triple bond is present between the two carbon atoms, that is, you can say ine. Okay, clear? Alk group, we have to know meth, eth, prop, but, pent, ex, ept, oct, non, dec. Then single bond ane, double bond ene, triple bond ine. Ane. So now come to the point. If meth plus ane. So what we can say? Meth plus ane means the carbon must be the single bond. So meth plus ane, methane. In methane, all are single bonds. So if all are anes, for example, eth plus ane, ethane, methane, ethane, plus N, butane, propane, pentane, hexane, heptane, octane, nonane, decane. So all are plus ane. Okay, now one carbon, that is alk plus ane. Alk plus ane is called what? Alkane. You can say alkane. What is that? Alkane. Alk plus ane. So meth plus ane, methane. Alk plus ane. So now alkane. Okay, this is the story of alkane. All alkanes have only single bond between the carbon atoms. Okay, it's very easy. I will tell you the structures now. Methane, butane, how the single bonds. First you have to know the namings. Methane. Alk is what? Alk is meth, eth, pro, bute, penta, hexaptane, okay. So alk, ane. So alkane mean methane, ethane, propane, butane, pentane, hexanaptane. So this is called the alkanes. And if these alkanes are in the ring form, cyclic form, we can say cycloalkanes. If ring is there, ring, cycle, so we can say cycloalkanes. Cycloalkanes. Okay? So now, we are going to discuss the alkane and cycloalkane structures. Okay? So just the alkanes and cycloalkanes are what? Just the single bond is present between the two carbon atoms or more number of carbon atoms, or carbon hydrogen or carbon carbon. Okay, only single bond is there. That is chain like structure is called alkanes, and in the cyclic form or in the ring form, that is called cycloalkanes. Alkanes and cycloalkanes. So what are the structures we can see now? So what is this? So now we have to see that one by one structure. Okay. For example, meth plus ane, methane. So meth means only one carbon according to this one, single carbon, single carbon. So carbon carbon, but except this one. So there is only one carbon, single carbon. There is no two carbon atoms. Okay, we can take the hydrogen. 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 So yesterday the chemical nature I told you in the introduction chapter, in the introduction lesson, yesterday video. So what are the chemical nature? That is the hydrogen is a single bond and carbon having the 4 carbon. These are the most important. These are the carbons having 4 electrons around the carbon atom. 4 electrons are present around the carbon atom and single electron is present in hydrogen. That is in a covalent nature, the carbon and hydrogen, 4 hydrogens sharing with the 4 electrons with the 4 hydrogen and carbon atom. So mean here the only single bond is present, the carbon and hydrogen. Single bond is there. So meth plus ane, so methane structure. This is called the methane. The structure of methane is methane. Okay, so here the 4 valence is there. So there is the 4 because the 4. So you have to remember the structure comes from yesterday class. So this is the structure because these electrons are sharing between the carbon and hydrogen. Okay, the bond is there, only single bond is there between the hydrogen and carbon. So ane, so methane. So methane. Okay, is it clear? Okay, now we can say ethane. Now eth means 2 carbons. Okay, we know the 2 carbons. So 2 carbons. So remaining is hydrogens. Okay, remainings are hydrogen, half hydrogens bond with the 2 carbon atoms, but the bond between the carbon is only single bond, that is called the ethane. Here also sharing with a pair of electrons with carbon and carbon hydrogen, 6 hydrogens and the preparation and properties we will see in the next chapter. Just you have to know that alkenes and cycloalkane structures. Okay, first of all we have to clear the alkanes, cycloalkanes. Like that, propane, 3 carbons. This is the propane. Butane. So every carbon is having the most 4 bonds, See, in this, so every carbon atom is having only 4 bonds. 4 bonds only. See, for example, you take this carbon, 1, 2, 3. One is with the carbon, another 3 are the hydrogen. So 4 electrons sharing with the 4. And this one is the carbon 2, this side and this side and this one. So 2 hydrogens, 2 carbons, mean 4 bonds. So 4 bonds are present around the carbon atoms. Every carbon atom like pentane, hexane, heptane, octane, nonane, decane. Okay? Total number of bonds are only single bond between the two. So don't think total number will be 1, 2, 3, 4. So 4 bonds are there. Not like that. Just the single bond is present between the 2 carbon atoms. You have to remember like that. Okay? Is it clear? So please note down. Methane structure, ethane structure, propane, butane. So you have to do, these are the, you take the pentamine, 5 carbons, hexamine, 6 carbons, heptamine, 7 carbons. So all are, first of all, take that carbon and write the bonds, and remaining you have to fill with the hydrogen. So if nothing is there, that is the hydrogen. Okay? Hydrogen is the single bond. So active. So you do in your house. Okay? If you have any doubt, please ask me or put a comment box. Okay? So this is about the alkanes. And what about the cycloalkanes? Okay? Cycloalkanes mean, what is the definition already I told you? In cyclic form. But before going to that, so we have to know that how many types we are going to write this one, skeleton structures. Okay? For example, you take the skeletal structure of the pentane. So pentane you have to take. So how many carbons? 5 carbons. 1, 2, 3, 4 and 5. So here we can write like this. So this is the one form. Okay? And another form. 1, 2, 3, 4, 5. If there is no, anything is not there, that is, I mean, hydrogens are there. So why I am telling you are write all this skeleton structure. So here the third form is, you can write the 1, 2, 3, 4, 5. So this is 1 carbon, 2nd carbon, 3rd carbon, 4th carbon, 5th carbon. Just so dot, for example. So if we are writing like this, 1, 2, 3, 4, 5, you have to remember like that. Just remember. So now, so how many is there? 1, 2, 3, propane. If one bond is there, ethane. So for methane there is no like this type of structures. For hexane, 1. So 1, 2, 3, 4, 5, 6 hexane. Not like this. So just you have to remember like this. So no need to write always these things. If you write like this, so this one. Okay? So why am because this is the shortcut method and easy to write. In examination also, in IIT exam also, final exams, they will give you like this, not like this. So you have to remember, for example, here. So here we can write this structure CH3, because the carbon is on the 3 carbon atoms are there, 3 hydrogens are there, CH3. Then CH2 mean 2 hydrogens are CH2 and CH2. Next CH2. Then CH3. So how many? 1, 2, 3, 4, 5. So either like this or like this or like this or like this. See. So if you are writing like this, so this is the structure. This is the actual structure. CH3, CH2, 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 CH3. Or simply we are writing like this. Only lines. If you can understand, it's very easy. So these are the lines, only simple line. For example, this line, CH3, CH2, CH3. Propane, 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 pentane, propane, pentane. So understand? So these are the structures. Skeleton structure. We can write skeleton structure. So understand why? Because these are, yesterday we have discussed the bonding. So every bond, CH3 means, so bond is like, for example, write as CH3. So you have write like CH3. So C mean having the 4 bonds between the hydrogens and carbon. So same just like the CH3. Or simply only one line. So one line. Behind one line, what is there? This much is there. Behind the one line, so one line means this much. For example, CH3, CH2. So here one line means CH3, CH2 is there. Mean one carbon is there, 2 carbons are there, 5 hydrogens are there in one line. So one line, simple one line. For example, one line is CH3, CH3. So total 2 carbons, 6 hydrogens. In this line, so here because the CH2, one more carbon attached mean here 5, here 6. So in ethane, just one line. One line, if you are writing the one line, that is ethane. If one more line, propane. So one more line, butane. 1, 2, 3, 4, butane. Like this. This is the organic chemistry namings. It's a very easy. Okay? And now, so you go for the cycloalkanes. Okay? So now, if you have any doubt, ask me later. So CH3, CH2, 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 pentane. So we have to write like this, or like this, or like this, or like this. All are same. Okay? So now we have completed alkanes. So now cyclic alkanes mean alkanes in cyclic forms. Alkanes in cyclic forms. So are ring forms. So cyclic plus alk plus ane. So cycloalkanes. Okay? So at least in these cycloalkanes will start from 3 carbons. 3 carbons mean it will start from not methane, ethane. Just start from probe. Start from probe. Okay, now from here, propane. So cyclic plus propane. So propane in the form of cycle is called cyclopropane. So propane, for example, CH3, CH2, CH3. This is the propane. So we can write this one is like this. Okay, 1, 2, only this one. 1, 2, 3 carbons. So if these are in the cyclic form, so how can you write the cyclic form? This one. So this is the cyclic form. So see here in the cyclic form we can write here CH2, CH2, CH2. So what is the difference between this one and this one? This is the alkane, this is the cycloalkanes. But the number of carbon atoms are same, number of hydrogens are same. So you, for example, calculate hydrogens 3 plus 3, 6 plus 2, 7, 8. Here also see, so 2, 2, 2. My total only 6 hydrogens. Number of carbons are same. So 1, 2, 3. 3 carbons. But here 6 carbons. So hydrogens are minus 2 hydrogens. Here 6 hydrogens, 3 carbons. Here here 8 hydrogens, here 6 hydrogens and 3 carbons. Mean, so when propane minus 2 hydrogens, mean here, so propane last 2 hydrogens minus 2 HN, so will give the cyclopropane because the 8 hydrogens, so here the 6 hydrogens, but the number of carbons are same, they are in the cyclic form. So here the propane, so 3 carbons, 8 hydrogens, here cyclopropane 6 hydrogens, 3 carbon, but the difference is this is a cyclic form, this is the chain form and cyclic form. 2 hydrogens are less in this cyclic form. So you have to remember, sometimes they will ask you how many hydrogens are less or what is the difference between the cyclobutane, cyclopentane. So just 2 hydrogens are different here. So in the case of butane, so say butane, so this is the butane. So 1, 2, 3, 4. So CH2, 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 CH2. So here also mean 2 hydrogens are less. 2 hydrogens are less. So total 4 to the 8. 8 hydrogens in cyclobutane, so 10 hydrogens in the butane. So 10 hydrogens, CH3, CH2, CH2, CH3. So 6 plus 4, 10. So mean C4H10. This is the butane, whereas the C4H8 cyclobutane. So simple thing here, alkanes minus 2 hydrogens is called the cycloalkanes. Just you have to remember. When chain, you remove the 2 hydrogens and attach with a ring. So mean loss of 2 hydrogens from chain form of alkanes to give the cyclic form. So all that, so we can write now, see, note down all these: cyclopropane, note down, cyclobutane, cyclopentane, cyclohexane, cyclooctane, cycloheptane. Like this, 1, 2, 3. So 3 carbons, 4 carbons, 5 carbons, 6 carbons, 7 carbons, like this, up to decay. So this is about the cycloalkanes. Alkanes and cycloalkanes are completed. So today we have learned what are that, just alk group, chain form and cyclic form, alkanes and cycloalkanes. Okay, tomorrow or in the next video, so we have to look at alkenes and alkynes nomenclature. Okay, so thank you very much. So before going to do, I request you please subscribe my channel. Thank you.